All right. So we start again. Continue yesterday's problem. Actually, we haven't started. Yeah, you haven't started, right? We were only discussing the problem as a connected components problem. Yeah. Okay. So connected components it's a problem in graph theory, right? When you have nodes connected in the graph, right? How many components are there in the whole graph? So it could be that a group is connected to each other, another group is connected to each other, another group is connected to each other, but between these three groups, they are not connected to each other. So you have three groups, you have three connected components. Ya, kayak gitu. So in this example, sample input 1, age, yeah, there are three pools of age. 1, 2, and 3. The third one has 4 age connected to each other, right? And the next example, coba scroll down. Next example. Yeah, it's also 3. Sorry, so 2, because the first one is connected. The first two are connected. Yeah. Now the question: how do you do this? How do you implement? So last night I already told you that you need to do depth first search. Yeah. What was depth first search?
Yeah, going down deeper to go to the next neighbor until there's no more neighbor, and then we go back, check again behind. Is there a neighbor? And then when there is, we continue until we get stuck, and then we continue that until everything is found.
Yeah. So we go deep to find everything that is connected. Then we backtrack until everything that is connected to that initial point was already found. That means the whole connected components is already found for that one connected component. Then we move next to explore which the next items or the next nodes that are not yet explored. Yeah.
Yeah.
Yeah. Well, that's quite a long logic, Mas. You can separate into the new line. Or do you want to make your code full screen? Yeah. Yeah, just shift a bit dulu. Yeah, it also works.
Wrong. Okay.
Okay.
I J plus 1 plus 1 Nah. Then minus we create a vector of integers. No, pairs. No, not this one. The other one. Oh, yeah, this one. T plus pair. Pair 1 dot first. Pair 1 dot second.
So you can create pair int, right? For the coordinate, to represent the coordinate.
Vector.
Then you can have vector of pair
int.
Bracket is sharp bracket. Yep. You can call it apa? V or what? Yeah,
Coordinate.
can, yeah, course, yeah.
Course. Okay. And then graph, and then graph. Okay, I need in one graph I j equal to and then we check.
Why do you use while? I don't understand why you use while.
After that, we change the I and j.
But
Yeah.
you want to append to the stack, right? You want to append to the vector.
Hmm.
You don't need to handle it in your while. You're appending the list of things to visit in the vector.
Then that first push. No. First dot first. What is first? Okay. First dot first go.
Course is a vector.
First equals I first j dot first equal j. Hmm.
Where is course I? You haven't even appended anything. You cannot call course I.
Hmm?
You haven't appended anything to course. Course is empty now. So course I is empty. There's nothing. It's null.
Then why is this?
That's graph. It's not course.
Yeah, but graph is vector. There's a vector in a vector, and you said doesn't. No. Do I do a pen? Okay, open. Vectors, force, dot push back there. No.
Yeah. New pair, right? Yeah, okay. You don't say it, you don't call it pair. Pair is a keyword. Okay, yeah, okay.
Means
Good.
pair.
P equal to what?
Hmm?
You want it to be equal to what? What is the coordinate here? Okay, so you find the syntax. Is that the correct syntax or not? I think that's not how we go. Maybe it's a function make pair. P equal to make pair kan?
No, it's
Oh, like that is it? Okay. I see. Okay. Okay, that's how the syntax is. Okay.
oh,
And then you process every element in the vector, right? Now you have one element in the vector, which is the first point. Yeah, kan?
yeah.
Now you need to append the neighbors. If the neighbors has -1 lah, you check the 4 neighbors 4 different neighbors. Diagonal is not applied. Yeah, diagonal. So you check the 4 neighbors, right? If it is -1, then you append that also, right? And then you keep on doing that, right?
Yeah. -1.
What is?
Parse dot push. No, I have to create a new pair. Pair int p.
Actually, you can just push back make pair, right? Push back make pair gitu di dalamnya. You can do that, right? Can you not? Itu tadi. Scroll down a bit aja. Just scroll down a bit aja di situ. In the kick to kick tadi itu udah ada. Kick to kick tadi loh. Kick to kick browser.
Oh.
Browser. Nah, scroll down a bit aja. Dia ada make pair kan? Scroll down lagi.
Okay. Pair 3 equals to make pair.
Nah, you can just make pair. So you can just push back make pair kan?
No, you have to create the make pair. Oh, really? Make pair ij.
Yeah.
Else if.
No, it's not else, right? You have to check every one of them.
Yeah, else if. Okay. -1. -1.
Good.
And this one. That's +1. 1. -1. And the else.
Kenapa else? Why else? You have to check every neighbor. It's frozen. No, something happened. Oke, Mac bisa crash juga ya. Ternyata Mac bisa crash juga. Let's wait until so the problem was this one. Yep, this was the problem. Okay, back online ya. Mesti share back online.
Yeah. I still have to share my
Can you? Yes, you have to share your screen.
Okay. Share right. Yeah.
Okay, Mas. The logic goes like this, yeah. You start from a point, right? So that point you put into the vector. you append into the stack. So let's say you start from this this book gitu. You put here. And then you check the neighbor of this book, right? You check the neighbors, what are the neighbors of this book? And let's say you found, okay, there's another one, there's another H. Then you put it on top. And then you check the neighbor of this book, right? Like that, right? Then it's like that. So what actually happens is you need to process the element in the vector one by one until you complete everything. Once you complete everything, that means it's done. Everything that is connected is all explored already. That's the idea. So what is your while loop? What should your while loop be?
Okay.
No, not there, not there. In the after push. Okay, what are you doing?
And then
yeah, after you push back a book, so a point, right? A coordinate, you have a coordinate, right? Yeah, while apa? No. No. You understand the logic or not? So you start from a point, right? You add the point to the stack. Yeah, kan? And then you check all the neighbors. If any of the neighbors and all the neighbors have are valid -1, then you add all those neighbor into the stack, right? And then you check the top of the stack, right? Then you check all the neighbors, kayak gitu terus kan? Until you finish processing all the neighbors, you are stuck, right? Then if you are stuck, then you can remove it from the stack, right? You start removing it from the stack. You say, I'm done. I already update this to the pools. And then you go to the next one also. You do the same. Check all the neighbors. If has neighbor, you stack them, all them into the stack. If don't have, finish, stack, that means you can pop. You can pop and update. That's the logic. So you continue doing this until apa?
Until there's no more neighbors who have -1.
Yes, yes, but the whole thing, like from the beginning, you started with adding one thing into the stack, right?
While
So you do all this until apa? Huh? You do all this processing until apa? You add a coordinate, right? And then you add the neighbors. And then you take the top one, you add all the neighbors. Kayak gitu terus. When you're done adding the neighbors, then you start popping. You start popping. So until when? Until what, brother? You finish everything.
Course is not empty. Empty.
Exactly. Yes. That's how it works. While course is not empty. How do you say course is not empty? Itu Python nih.
Okay.
Size.
Oh yeah. Size. Yes. Course dot size not equal 0.
You should make it a habit. You say greater than 0. Yeah. Okay. So while it's greater than 0, what do? You take the top one, right? You take the top one, and then you process all the neighbors of the top one, right?
Yeah.
So you don't say sorry, you actually it's not graph actually. What you have is just the matrix of the field. It's not a graph, but it's okay. You call it graph. It's actually just a grid, right? It's not graph. It's just a grid. So while your vector is not empty, you take the top of that vector, right? Or the back of the vector. The back of the vector, and then you check the neighbors of those. Yeah.
Oh, then course Cars dot size. This one.
To make it easy, just make a temporary variable aja. It's too complicated if you have to write everything like that. Kayak gitu.
Okay, so what
Just call it top maybe or current.
Okay, it. Oh, it has to be pair. Is it a pair or an integer? What is it that? Um,
Equal to apa?
equal to.
No, you don't use bracket, right? It's just a pointer. You are not creating a new one. Just want it to point to the last element, right? You want it to point to the last element.
Cars dot size.
Yes, good. It's basically the last element. Yeah, good. Now,
Yeah.
if what?
If the
Maybe to make it easy, just call it XY, right? XY.
x x
No. Leave it. No, I mean you create a new one, XY.
okay. Then
Create a new
we
one, XY, and X is the coordinate that Kur is pointing, right? XY is the coordinate that Kur is pointing.
x
Easier
equals
for you, right?
first
Yes.
and y equals the second.
Yes, very good. So it becomes XY.
Y. Y x x y y minus 1. Yeah. Then
Your IJ. Your IJ masih ada tuh on the end tuh. Make pair-nya masih IJ tuh. Okay. So now where the vector is not empty,
yeah,
you keep on adding, right? You keep on adding.
the coordinates.
If it is -1, you add, right?
Hmm.
Then what do you do next? Then you continue, right? Continue looping, right? Because you added something, then you need to continue, right?
Yes.
Wait. You need to continue looping. When do you start popping? Yeah. When do you start popping?
When none
You
of
start
them.
popping if you haven't added anything, right?
Yeah.
Yeah. How do we say that? Yeah. When you haven't added anything. Actually, the best way to implement this itu pakai ini recursive function actually. Tapi okay, let's just try using while loop dulu ya. You know, if it is recursive function, it makes sense, right? So you are in this node, you append this node, ya kan? And then you process this node, right? You process this node, and then when you append a node, then you call a recursive function. I want to process this node. And then you append a node, then you call recursive function. I want to process ya kayak gitu kan. Tapi it's okay. Let's try using while dulu ya.
Oh, okay.
So how do we do this? Kalau while, so Yeah, if you didn't add anything, then you pop, right? Then you start popping. If you haven't added anything, you start popping.
We make a integer size over here, and after that, after we add, we make an integer size. If the integer size after we add is the same as the not integer, if the coordinate size before we push
Oh
back.
yes. That's a good idea. Good idea. Let's do that.
Hmm,
No, you can always define it inside juga kan. It's not everything have to be defined there.
yeah, but then it will be defined again and again. Is it can?
Nggak masalah kan. It's okay kan. You only need it in this loop kan.
Uh, size
Before. Just call it before aja.
before.
Size is a careful. Size is a keyword, right? So you need to be careful. Actually, not really a keyword, but yeah, just
Size if for the size smaller than equal to before.
then you need to start popping, yeah.
Hmm.
Then you update the last node. This is where you say graph equal to pools. So you don't do it on the top. You don't do it in line 27. You don't do it in line 27, right? You do it in that individual when you process. You go very deep, right?
Yeah.
Then you update the node and you throw it away, right? It's updated now. You don't do
Oh,
it there. You do it, yeah. You do it, so yeah.
yeah.
Eventually, your first node will also be updated also, kan? Because it will be the last item you popped out, right? Because it was the first item you put in. Yeah, good.
X, Y equal to
And then pop, and then
yeah.
you pop it, right?
Is it
That means
pop?
you are done. Yeah, I think it's pop.
Dot
Course
pop.
dot pop. Yes, just say pop back. Yeah, itu correct, pop back. Is it pop or pop back? Yeah, pop back lah. Yeah, that's okay. If it is pop back, it's pop back. You wanna search first, is it?
Yeah, no, it's okay. Okay. The graph.
Okay, so you pop it.
And then we go to the next one.
Then you go to the next one.
Which is the last one.
You will always go to the next one, right? Because then you'll just continue and it will just pick up what is the topmost item there. Yeah, and then you will just do, right? Yeah, I think this logic is done already, yeah?
No,
Anything
no.
we miss? Huh?
When you go back,
Apa? There is no going back. You will just keep processing the top of your stack until you finish.
but then you can process the same coordinate 2 times. You can append, you can push back the same coordinate 2 times.
Oh, because we did not update the pools before, yeah? We only updated after, yeah? Okay, you're right. Then we should do it before. Then you are right. You move the graph x, y equal to pools itu, you move it to, why else? You need all the neighbors. It's not just one of the neighbor. You need all the neighbors.
Okay. Then
No, yeah. So you update graph x, y equal to pools itu, you do it before your if statement, right? Before you push back. Actually, does it matter, yeah? Doesn't matter, right? Does it matter? Matter, yeah. Oh, Okay. You need to, when you push back, so basically whenever you push back, you need to update it to pulse whenever you push back, so that the next time you will not process it again because the number is updated. It's no longer -1. That way you will keep whatever you push back to the factor, it will only be pushed back only once, right?
Yeah. Oh.
So whenever you push back something, together with pushing back, you also need to update it. You need to update the, yeah, correct. Yeah.
It is good. Mm. And then enter. Okay. 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 And then
This you need to update. Need to move that line, yeah. Just move that graph XY, you copy, yeah. But it's not XY, right? For each one of them. And then
oh
you
yeah.
need to do the XY also on the top when you first time push. So what you did was correct also. Okay, you finish this too. You finish this correcting the coordinates too.
But it's already here, right? Yeah.
No. We should do it when we push, remember, so that we don't process it together.
Ah.
Yeah. So this line 49, you need to move it back to where it was. Remember? What are you doing? No. Not there. Why? What are you doing? XY on the top. When you push the first one, XY. IJ.
IJ.
Yeah, the original place where you put it. It was there, right? Remember?
Here.
Yeah. You update the graph also there.
Then graph IJ equal.
What are you doing? What are you doing? It's a bug. What are you doing? It's a bug. That was correct. You just have one character bug.
J. Popo.
Yeah, you use equal just now.
Oh. Oh. Oh, I just see that.
Yeah.
Okay.
Okay. Now you can remove that yang di bawah itu, you can remove yang graph XY equal itu, you can remove, right? Because we just need to no. Don't rush. No, not the whole thing. Undo. Just the line. Yeah, because you already move it back up. You still need to pop. Right? You get it or not so far? You look confused.
No. No, I don't get it.
Okay, which part you don't get it?
Which part do I not get? Excellent. I don't get why we have to make it
Update.
update it when we push it back.
Yeah, so that if that coordinate that we push back, yeah, if it happens to be the neighbor of another node yang we will be processing later on, it will not be added again because we already updated to a number that is not -1. If we did not update it the first time, the next is again, and we will stuck in infinite loop. Yeah?
Yeah, understand.
Okay. Got it, yeah? Okay. Now, okay, so from the top to the bottom, you understand the logic, yeah? So you start from a point which was IJ, and then you update that ij to the pools, right? The pools number, ya kan? Ya kan? And then you find every node that is connected to that pool, to that first coordinate, ya kan? And the way you do it is you append to stack all the neighbors that meet the criteria while updating the neighbors also. Then once you are finished, you are stuck, then you will be popping back, popping. Yeah, and so on, right? So that's what you do, okay? You got the logic so far, yeah?
Yes.
Okay. Now there is a bug, Mas. There is a bug in your from row line 33, line 37, line 41, line 45. It's all buggy.
33, 37, 41.
Basically, whenever you call the array, when you call with x plus 1, x minus 1, y plus 1, y minus 1, there is a risk of a bug. What is the risk? You need to make sure that. Okay, imagine if x is 0, what will happen with x minus 1?
I have to make sure that the x plus 1 is in the scope. It's inside the scope.
Yeah. So what you can say is in the if statement, within the if statement itself, you can check x is less than. No, you need to do it before, so that it is checked first. If you do it after, then it will call your array first, and you will hit the bug first. You will hit the array out of bound. Okay, you can do it that way also. You create another if. Yes, it is safer. Yeah.
If x
is less than.
Wait, x is which part? X is this. Yeah, what is that? If x is greater than this.
It's actually up to you, right? X, Y, it's really up to you. You want it to correlate to. Actually, yeah, depending on your loop, yeah. You need to check your for loop, Mas. How do you loop ij? How do you loop ij? Yeah, so I itu follow apa? I in your for loop itu. Nah, I itu apa? I itu R.
I is
J itu C.
J,
Yeah. So X is I, X is R gitu kan. Then the boundary of X itu R gitu.
Then this is X. Because it's I. Oh, okay, I understand. So then the which is good. If X is greater than R. No,
is it
if
greater than?
Equal.
Equal? Kok equal?
Greater x plus 1 will become 4. Got
yeah, but you when do you execute it? Then it's not equal, right?
No,
not correct. It's not just when it is equal. No, it's even worse. So when is it safe for you to call x plus 1? Yang x minus 1 dulu deh, easier. You don't need to keep on looking the problem. You don't need to. You just need to know that x is bounded by 0 until r minus 1, right? That's it.
Yeah.
X is between 0 until r minus 1. So how to make sure that you can execute that safely? X minus 1 will not give you error. So when will that? When is it? When x is what?
X is greater than 0.
Yeah, this is the easiest part, right? So now what do you need to do for the x plus 1?
X plus 1. Oh, this one. When x is smaller, when x is smaller than r.
Is it smaller than r? Are you sure? What is the biggest number that is still smaller than R?
R minus 1.
So what will happen if it is R minus 1?
Oh,
What will happen if X?
we start from 0.
Okay, good.
1. You start from 1.
Yeah, very
Then
good. Okay, same thing here, right?
Y smaller than C minus 1.
Very good.
Then if Y is greater than 0.
Very good.
Okay. Then we've got our side. Yeah.
Yes. Yes. Now the logic is complete. The code is complete now. So what happened is you process one age, ya kan? One age you process, and then you update it to the pool number, right? And then you keep on appending the neighbors until you are stuck. When you are stuck, you start popping out, popping, gitu kan? So it works now. It's done. Yeah. Now, how do you increase the pool number? You must increase the pool number, right? You haven't increased the pool number. When do you do that?
You increase that when the course size is 0.
Yeah, that means after your while loop is done, right?
Yeah.
Yeah. So where is your while loop? Until when is that? Yeah, good. Okay. Now you can do it like this, or what you can do is also you increase the pools when you start. You increase the pools number when you start. So in the beginning, when you found that first node itu, when you see, yeah, this one here. Yes. You can also do it that way. Then you start pools from 0. Gitu. Yeah, and then you remove the pools plus plus yang di bawah, you need to remove it.
Yeah.
The pools plus plus that you added just now in bottom, at the bottom, you need to remove it. Already? Okay, you didn't have it there. Okay, good. Yeah, this looks complete actually. You wanna try? Okay. Okay, definition problem. What is bool C? You replace C again. C, you use C again. That's why you need to use variable that's explainable, yeah? Okay, 6F. Okay, time to debug now.
No. 6F, I think maybe it's infinite loop.
Okay, I think I know, Mas. Your vector of vector. I remember I noticed that, but I did not tell you. Your vector of vector. You never push a vector into your vector of vector. So you cannot call graph I. You cannot. It's empty. There's nothing. You need to push dulu. You need to create dulu. Graph I itu you have not created. You haven't created graph I at all. You haven't pushed a vector of integer at all.
Wait. Okay. Then if like that, then I have to create a vector.
Do you create it there? Do you create it there? Where do you create your vector?
Vector.
Yes.
In V, then graph dot push back V.
Yeah. Good. Coba. Is it still error if you do this?
No.
Amazing! Wow! Immediately correct in the first try.
Okay, let's
Amazing. Wow. Okay, you study again your code completely.
Wait, wait. Hey, look, it's faster. No, no, it's slower. Is it? I don't know. Okay.
Wow, your code works. Wow.
Huh.
Okay, I did help a lot, but still, I'm also still surprised. You wanna try to submit and see? You study your code dulu. Tell me which part you don't understand from the top to the bottom. Make sure you understand every line. Why that line is there?
So
You know.
walls, and then you create a pair with the coordinate, and then you put the coordinate into the coordinate slit vector, and then you set the graph to become the pool number, and then while there are still coordinates inside the coordinate vector, make a pair which is the current coordinate, and x is the first coordinate, y is the second coordinate, x and y. But basically, it's actually the other way around. Then in before, which is the size at first. And if x is smaller than r minus 1, yeah, I understand it. And I check the graph x plus 1, y equals to minus 1. If x greater than 0, 1, yeah, and when the size is before, which means something, then there's nothing, then go back. Oh, okay, I understand.
You understand, right?
Yeah.
It's beautiful, isn't it? Depth first search. Like you can make use of stack. So you process, you keep on adding. It's like doing homework, right? Ngerjain homework gitu. Okay, I got a homework, but this homework has neighbors of homework. Okay, I'll put this homework on
And
top of my desk, right? And then I process all the neighbors. And then, I still have neighbors. Until you run out of the neighbors. Okay, finally I can finish this homework. Throw this away. And then check the next homework. And then, does it have neighbor? Keep on. It's like the stack of work. Until you finish all the stack of work, you are done. That means you have already completely exhausted all the connected components, all the connected nodes in that particular component.
potato.
Yeah, and then you can move next.
Go back.
Okay, let's try. Let's try now. Submit.
We haven't submit.
You have not submitted.
Oh, okay.
Okay, the moment of truth. Will
Is
it be
it
correct? Almost 1 hour. Whoa!
grabo.
Amazing.
Oh, but
Bravo,
it's
bravo, bravo.
I wonder what's the time limit.
No, compile time is okay. There is no. I don't think there is a limit for compile time. But it's the runtime yang ini, runtime yang
Oh,
apa? Ya, runtime yang. Wow, immediately. Wow, this is great, Mas. You actually, yeah, that means you
and
have implemented depth first search
that means
already. Wow.
correct. Everybody gets correct. See, everybody. That's why the average. I got the average, but I still don't know the quad
And
potato.
actually, we cannot see other people's code ya.
No.
Ini nggak kayak TLX ya. It's unlike TLX. TLX you can see other people's code.
See, I go to this one. Cannot. Oh yeah, I have to click to the one. See, I cannot.
Oh, but you can see whether they were successful in all the subtasks. Yeah.
What is this? Panda eyes? Wait, what?
You wanna check Panda Eyes? Is it a difficult problem or not? Or you check you find in the problems list. Which where is it located at? Is it do a find lah? Find.
Then fine.
Command F.
Oh, command F.
Command F.
Panda eyes.
it far from you?
Wait, no, not really. Oh, that's Fizz
Already
Buzz.
far?
That's Fizz Buzz. Fizz Buzz. I guess
Yeah.
in TLX I see Fizz Buzz. In Katis I see two Fizz Buzzes.
Yeah.
I
FishBuzz
wanna
is everywhere. FishBuzz is a famous programming interview test.
Mhm. Have you heard of the it's a test. Slightly harder. CAB, print all integers from S to E inclusive on one each line. Replace the integer with fixed with by A. Wait, I've done this before, right? In Katis, in Python. Yeah,
Maybe.
yeah, I did.
I think yang Katis was a bit different. I think was probably a bit different.
iostream.
Oh, you want to do that? Okay. Okay, can.
Oh, the bracket. Yeah. Ustream using name. Nah, I think I'm just gonna use modulo. Very easy. Modulo. That's all. Min min a start and a
Good. Yes.
min. What's the order? There will be the order is S E A and B. Oh, okay then.
Start N A B.
Start and A B. For int I equals start, I smaller than end, I plus plus, I wrong order. Okay. Wrong. If I modulo A equal 0, if I modulo B equals 0, see out is buzz. Can there be extra line after the last input?
I think no problem usually. Usually it's no problem.
E minus S plus 1 line. E minus S, 8 minus 1 plus 1.
I think it's okay. Don't worry about the new line dulu. Nanti kalau salah aja baru presentation error kan. If there is presentation error then yeah.
Yeah. Is. Was it not?
Okay, you do it this way, can.
Then else. Else. Then that means I is not. It's not modulo by A. See out. Buzz.
Salah lah.
Why? Why is it wrong? Oh. If I modulo B or 0, then else. Yeah. What was it? I. And then.
Just like that, really. Why does it look so easy?
Why does this take 339 milliseconds but this take shorter?
Try running again. Try run it again.
Oh, how come suddenly? Wait.
Yeah, so that means I think it's the compilation time was taken also.
Oh, then how come the compilation time so long?
Yeah.
Okay. Wrong
compilation time.
Wrong button. I think I should use my mouse. Or because my hand. presentation? What?
Check your for loop. There's quite a lot of wrong answers.
Did I do something wrong?
Oh, start until end. Okay. What do you miss? Yeah.
Maybe. Let me check the problem again. Is there something wrong? Mm. Oh, oh, see, it's so big, so big. But what is 10 to the power of 18? It's 18 digits.
Actually, they did say A and B will fit into 32-bit signed integer, but they didn't say S and E.
Yeah, di
Yeah.
SN.
Yeah, S and E can be very large. Okay. Ya udah coba aja. Your for loop then is it int then?
Long. Yeah, because long.
Hmm.
Can I just do
Ya
start
udah coba submit.
plus?
Can you just what?
Is it necessary to make an integer equal to another to start, or can I just take out this line and just start and start? So
Then you need to define start somewhere else. Basically, kalau di C++ itu, in C++, your for loop has 3 statements. The first one is the initialization statement. So that statement is executed the first time the for loop is performed. And then the middle statement is an if statement, right? It's a condition that will be checked after every loop. If that condition is still valid, is still true, then the loop will continue. But if it is no longer true, if it becomes false, then the loop will stop. So that's the second statement. And finally, the third statement is the ending statement, which will be executed every time you finish one step. Every time you finish one loop, that ending statement will always be executed. In this case, it's plus plus, right?
no, not always. Because if you
Yeah,
do
it's not
plus
always,
plus,
but in this case, it's
you do
plus
plus
plus.
plus I, then it will add first. Am I?
Yes,
Am I?
yes. Yeah, but I'm just saying that in this case, it's a I plus plus, right? So you can change. You can do not start like that, but you need to define first. Long I equal to start. You define first before your for loop, right? And then you can even keep that empty. You just for bracket and then semicolon. You can also do that. Because if you have nothing to execute in the beginning of the for loop, or you have already write it separately, you can just keep it empty. Oh, is it done? Yeah, long is the problem. Because berapa? 10 to the power of 18 tadi ya?
18. Too
10 to
much.
10 to the power of 18 is like what? It's 10 to the power of 18. 10 to the power of 6 is million, right? So it's million. So it's million trillion, which means it's quintillion, right? Yeah, quintillion. Okay, that's why it's still within long ya. Long berapa? Maximum 9 ya? 9
9
quintillion, right?
billion.
Yeah, 9 quintillion. Okay, so it's still okay.
What?
You want to commit your codes first that you have already gotten correct?
Oh, they have the translation.
Actually, you were jumping, yeah?
Yeah.
Check your problems, list of problems. Can we see how far did you jump? Just because you saw Fish-Bass and you wanted to do Fish-Bass. Okay, it's got a lot in between.
String line. I think I seen this name before. Yeah. There? Oh, easy. This one's easy. Huh. Okay.
You
Yeah.
want to do the hard one?
No, not
Okay,
yet.
you want to do event dulu.
Always translate Vietnamese. Yeah. Okay. Yeah. Does this cruel second grade teacher assigns a list of n? Yes. Yeah. For which best must determine their parity. Oh. Now listening. Not a program to read in the and integers and print even on the single line for even integer and likewise odd for odd numbers. Problem name, yeah. Input format, sample input. 2 integers, 1000. Output format, sample output, even odd. Okay, yeah, got it. Chinese translation. Bessie, I don't understand this. And then did it 25, did it even odd, did it female, did it, huh? Female. Yeah, okay. Even odd. This is gonna be, is there a trick to this? Is there some kind of catch? A twist?
The problem looks easy, yeah.
Yeah.
There could be some catch somewhere, yeah.
Could be. But I still have to use long. Do I? Or maybe, what is the time? What is the time? 1 second. What is the maximum?
How many? Yeah. What is the worst case scenario? Ooh, 10 to the power of 60. Oh wow.
Oh,
That's
then I
not
can
easy.
just get the last digit. Last.
Yeah.
But
You got it.
I converted to string and then converted to integer. Convert
You don't
in.
need to even convert it to string. The input is already in string, right?
Oh.
The input is already in string.
String s.
No, the first input is not the string, right? The first input is what?
1024.
The first input is how many input are coming, right?
Yeah. Oh, int int for int I equals 0, I is smaller than t, I plus 0, then I will have a string.
String s, yeah.
String s, then sin s.
Is it sin s? Oh yeah, okay. You can do that. Yeah. Yeah. And then
Get last character of
you
string.
can, yeah, okay. You can just use the bracket lah.
Back.
Oh, there is a back. Ah, that's interesting. I didn't know that. Okay.
Okay, so string dot back, and then how do you do story again? Story, right? Story.
Yeah.
Story like this, right?
Yeah.
Okay.
Or you just say int lah. You can just say, I think you can just call it int.
Int. Yeah.
Yeah.
No, wrong button, wrong. Okay. Int
S
back.
dot back itu, what is the result of s dot back? Is it a character or is it a pointer to that character? Coba lihat aja deh.
Oh, pointer. The last character of the string is the first character in the reverse string. So string R begin will give you an iterator to the last character. Oh, it is the other one.
Okay, so it's a character. Yeah. Okay, let's do it first. Let's see and test.
If oh. if modulo 0 is 2 is 0, count even else yang okay 2 1097 Okay. Expected output. Odd, even.
Your ini Mas, your apa quotation mark.
Ah.
Because it was then trying to print
Marvelous.
just like that. Cannot be that easy. How come so easy like that? I'm
Is
still
that,
suspicious.
is that going to be
I'm still
something?
suspicious. Whoa! Wow. Okay, that's good.
Okay.
That easy, yeah. Okay, that's good. That's good.
Next question. Hexagon. Hexagon is 5 sides, right?
Mana ada hexagon 5 sides?
6 sides. Yeah.
Mana tuh?
Pentagon is 5 sides. Oh, I'm mixing up my gons. Yeah.
Oh my god, you need to print hexagon. Okay. How are you going to do that?
Hexagon, right? Like I want you to print the end units long on all these. What? Oh no. There's a space. What's the
Of course,
space?
there's a space.
What's the space?
Of course,
1, 2,
however many that you need, right?
4, 5, 6, 7. No, 6.
6 lah, not 7 lah.
6. Ah. IO string using name space D is name and then
Oke, habis ini kita habis this problem kita break dulu ya. Sholat, dinner sama because later after Isya kan kamu sama Habibi. You will have a session with Habibi, right?
oh yeah, I forgot about it.
Yeah, after Isya at 30.
Okay, so there's 1, 2, 3, 4, 5, 6, 7. 7 times for this one. 7 times. 7 times. 13. 13. No. 14.
Oh my god, you are making the same mistake again. Why 14? Why 13?
Oh my god, what's wrong with me? 2 times n minus 1. Yeah.
Okay,
Yeah.
you want to do that going up and then going down, is it? Okay.
Yeah, of course.
Yeah.
Why is this the expected output? That's weird.
Yeah, it looks like that. Maybe you need to expand it aja.
See out. For in no. I make another integer, which is the number of more stars I have to create, because this one's 7, and after I have to create 1 more star for each side, and then 2 more stars. Yeah. Oh, wrong. Okay. A equals 0. For int I equal for int j equals 0, j smaller than n minus a minus 1. Space. Oh, I forgot to. Okay.
And then
for int j equals 0, a smaller than n plus a 2 times a, n plus 2 times a, j plus plus,
Oh, I see. Very good.
star, got a
Very
star.
good.
After that, we just and line. Is this correct? Oh yeah, yeah. Wait. And then I have to increase if if a smaller than n, then a plus plus, else a minus minus. This is correct. A is 0, a is 0, then 1, and then there's 3. 0, 1, 0, and then you have to add, then 1, you have to add. And here, then cannot. A smaller than n minus 1. Okay. 1, 2, 3, 1, 2, 3.
First test case juga.
Oh. Boom. Condition equal false. If condition equals true, then if condition a minus minus, else a plus plus. False. True. Is this correct? And God. Okay, what and not con.
When do you need to flip your condition?
When I have to make it smaller. When I have to make a smaller, which is when
Once you flip it, do you still need to keep on flipping it?
no.
Yeah, why don't you just flip it only once? That was exactly what you did. You flip it only once.
Yeah.
No, you flip it only once. So what is that condition when you flip it, when you need to flip it? There's only one condition. Only one time. There's only one time you need to flip it. Now you need to check your condition true and false. What do you intend with the condition?
When
What is condition? You should call it explainable. What is condition? Just call it apa? I want it to increase or I want it to. So just call it apa? Increase. Okay, ink. Okay. Then if it is increase, then why you do minus minus?
Yeah, I switched it by the change. And now it's the space. Oh, it's an X, not a. A capital X. Hey, don't laugh. Okay, fine, you can laugh. Okay, the capital X, but not. Okay. That was the problem.
Yep.
That was the.
Yeah, but your condition tadi memang salah. Your condition to increase and decrease tadi memang salah kan? Was it not? Was it not wrong? Maybe it was not wrong ya.
No, it is. If I do this, then
Ya, cuman apa your if tadinya kan nggak gitu. Your if tadinya kan less than and end kan. Less than and condition kan.
yeah.
Anyway, yeah. It's too complicated lah anyway.
I don't know an easier way for me.
Okay, good. Well done. Time to take a break. Sholat maghrib sama makan. Nanti habis isya kita ada session sama Habibian. Alright.
Okay.
Good job. Let's end the broadcast.